Right now you've had an introduction to the mole and why we would use the mole and why it's so important to have a quantity like that with teeny tiny little molecules and atoms that take so many of them to make a sample that you could actually see with your eyes. So today we're going to build on that concept of the mole being sort of like a dozen, and we're going to see how that fits in with chemical quantities. But for starters, I'm going to start with a cheese sandwich. And everybody always laughs at me with the cheese sandwich, but I think that it helps students a lot, and I refer to the cheese sandwich over and over again throughout the year. So if we think of a cheese sandwich as being one slice of cheese and two slices of bread, then we can use those ratios to figure out how much cheese and how much bread would be in a certain quantity of cheese sandwiches. And this is going to relate to how we would do the same thing with molecules. All right, so how many cheese sandwiches are in 2.5 dozen sandwiches? So this is sort of an easy gimme. So just like in the last video when we were practicing conversions and dimensional analysis, we need to make a plan first. So we know we want to go from dozen sandwiches to just number of sandwiches, okay? And we know that 1 dozen sandwiches equals 12 sandwiches. So that's our plan. So we put what we know out in front, 2.5 dozen, all right? And then what we want to find is what goes in the top, and what we want to cancel out goes in the bottom. So we want 1 dozen in the bottom and 12 sandwiches in the top. So 2.5 times 12 gives us how many sandwiches in 2.5 dozen. Now we can build on that by looking at how many slices of cheese are in 2.5 dozen sandwiches. So the first part of the problem, our plan is going to be the same. So we're going to have 2.5 dozen times 12 sandwiches over 1 dozen. And then we know that 1 sandwich has 1 slice of cheese. So that's our equality. So our conversion factor for that, we always want to put where we're going on top. So we want cheese on top. So 1 cheese over 1 sandwich is our last conversion factor. And so then we have 2.5 dozen times 12 times 1 is going to give us 30 cheese slices. Okay? And now the same thing down here. If we have 2.5 dozen sandwiches, how many slices of bread is that going to be? So this part is going to look very similar to what we just did, except that instead of 1 cheese, we're going to have 2 slices of bread in 1 sandwich as our last conversion factor. So 2.5 dozen sandwiches has 60 slices of bread. Now we're going to complicate things just a little bit. So if we take water molecules instead of cheese sandwiches, so each water molecule has 2 hydrogens and 1 oxygen, okay, just like our cheese sandwich had 2 breads and 1 cheese, right? So, and now instead of dozen, we're going to be using moles. So how many molecules of water are in 2.5 moles of water? So we know that we're going to go from moles to molecules. And just like when we went from dozen to just plain old sandwiches, we used the conversion factor for that. We're going to use that 1 mole is equal to 6.02 times 10 to the 23rd molecules. So this isn't a special number or anything. It's just a lot bigger than the 12 we were using for dozen. Okay, so we're going to start off with what we know, which is 2.5 moles, and then use our conversion factor. So if we know that 1 mole is 6.02 times 10 to the 23rd molecules, where we're going is molecules, and so that's going to go on the top, and where the units we're given that we want to cancel out are moles, and so that's going to go on the bottom. So we're going to get 2.5 times 6.02 times 10 to the 23rd, and then that's going to give us the number of molecules of water. So now we can build on this, just like we did with our cheese sandwiches, and figure out how many atoms of oxygen and hydrogen we also have there. So first we want to find out how many oxygen atoms are in those 2.5 moles of water. So the first part of our problem is the same again. We have 2.5 moles times 6.02 times 10 to the 23rd molecules of H2O in 1 mole. And then we know that in every water molecule we have 1 atom of oxygen. And so oxygen atoms is where we're going, so that's going to go on the top. So we have 1 oxygen in 1 H2O. All right, and then that tells us that we again have 1.5 times 10 to the 24th atoms of oxygen. Now we can do the same thing for hydrogen atoms. Again, the first part of the problem is going to be the same. We have 2.5 moles of water, and so that's times 6.02 times 10 to the 23rd water molecules in 1 mole. And then for every molecule of H2O, we have 2 hydrogen atoms. So we're going to have 2 H atoms up here and 1 molecule of water down here, and that's going to give us 3 times 10 to the 24th atoms of hydrogen. So that's it for this lesson. The next time we're going to take a look at how we can get from a quantity we can actually measure in the lab, which would be mass, to moles or molecules of a particular substance.